Okay, here we go. This is the S60-101. This is probably the most complicated part in the class to both model and machine. It has turned and milled features in it, including a bunch of internal features, including O-ring grooves and cross-length holes. Okay, but we're going to take it one step at a time, and we can do this. So we're going to go to our drawing, and we're going to take a look at it. Our primary view is the one right above the title block, and it shows that there's straight in on this counter bore with a through hole, and then there's a section view where the top view would be, so it's as if the part's cut in half along the line that's defined by AA. So we have section AA. And so you can see the inside, we've got two O-ring glands. There's a large diameter, then it steps down in diameter again for where the bushing part presses in, and then this hole is where the piston rod slides through. So the piston slides through this, and then the heating tube goes over that as a cover and engages with these O-rings to make a seal. Then we have two dowel pinholes of different depths, and that connects this whole part to the main post. And so this is a pretty important part. There's a lot of things that bolt into it, and other parts that go into it. The secondary cylinder goes into this counterbore. We're going to start with revolving the outside with the fins, and then we are going to revolve the cuts in the inside that are all based off these diameters. And then we will put in the holes from the side, and the last thing we'll do is probably put in this counterbore hole from the top. Alright, so let's set it up so that it shows just like this drawing. So we're going to do all our revolves with our profile drawn in the front plane. Alright, let's go to SolidWORks. We're creating a new file. It's a part file. Okay, we're going to turn on our primary planes. Okay, so most of our dimensions radiate from the right side. So we're going to draw the right side plane as the end. And so we're going to go sketch on the front plane, and we're going to look at that plane normal to the viewing plane, and we're going to draw a 2-point rectangle. Oop, wrong mode, that's center rectangle. Let's change back to the default, which is corner to corner. We're going to start in the center and we're going to go up. Okay, and then we're going to draw a center line that's longer, but it's going to be in alignment with the plane that intersects this. And that'll allow us to put in dimensioning as diameters. Let's set the length of the part by dimensioning the length. We go back to our drawing. The overall length of the part is 1 inch, 300 thousandths. Okay, and our main diameter is 1 inch even in the side view it shows. Okay, we should have a fully constrained sketch, and we're going to accept that sketch. We're going to look at it in a 3D view. We're going to highlight the sketch we just made. We're going to go to features, and we're going to do a Revolve Base, and we should have the cylinder. Now you could have tried to incorporate all the internal features to that revolve, but I'm going to choose to do that as a Revolved Cut. Okay. Alright, so we're done with that. Let's go ahead and do those internal features. Okay, so we're going to go to Sketch. We're going to sketch on the front plane. And we're going to look at the part in normal to the front plane. And we're going to go back to our drawing and study the drawing a little bit. So we come in, we step down in diameter, come back out to the same diameter, step down in diameter, step back out to the same diameter, and then we have 1, 2, 3 more reductions in diameter. So let's see if we can mimic that. We go back to our model. We're going to start with a line at the end. We're going to come in. We're going to jog up for one of the O-ring glands. Back down. Over. Up again. Across. There's our second one. We come to here. We're going to come down to a smaller diameter. In. Down to an even smaller diameter. In. And then our last diameter. And then it exits apart, so we want to try to see if we can pick up on the end of the part. So I wasn't picking up the silhouette there very quickly, so I'm just going to manually force it for the end to be coincident. I believe that's the right number of steps, but we'll see when I start getting into dimensioning. If I made a mistake, we're going to have to come back. Okay, so before we do any dimensioning, we want to set up some relationships. So I'm going to highlight, holding the control key down, I'm going to highlight these 3 lines, which are all the same diameter, and we're going to make those collinear. And then we're going to highlight the bottoms of the O-ring glands, and those are also going to be collinear. Okay, so they're the same diameter. Okay, now the width of the O-rings are the same. So I'm going to highlight the line that makes up the width, and we're going to make those equal to each other. Alright, now we'll start dimensioning. We need to create a center line. And it's important that that line is in line with the plane, so otherwise your diameter will be off. Alright, let's go to our drawing and start pulling diameter. So the diameter of the mouth. The mouth of our hole here is the largest one we can see in the side view, so it's 650 thousandths. Okay, so that got a little bit bigger and it turned black. Then our next diameter is the O-ring, which we have to reference the section view for, and it's 791 thousandths. Okay, so we got the proper height on those. Now we're going to step down to the next diameter. So we should be able to see that as the next size in, and it's 570 thousandths. Okay, and the next diameter is to accept the bushing part which you modeled earlier before. And we're going to put the diameter on that one, and it has a tight tolerance because it's a press fit. It's a 234 to 236, so we're going to call that a 235. Okay, and then our last diameter is the through hole. We'll go ahead and drag that one out to the left. And that is a loose fit for the loose slip fit for the piston rod, and it's 103 to 98, so if we were to go right in the middle of the tolerance on that one, it would be 100 thousandths and 5/10. Okay, now we need all our depths. Okay, so the dimension that's here depth on the drawing is 0.06, which is 60 thousandths. Okay, the width of our O-ring groove is 100 thousandths, so 0.1. And the next dimension is the inside of the second O-ring groove to the back of the part. Which is 490 thousandths. And then the dimension, I'll move that guy over a little bit. The bottom of the 650 thousandths bore is from the edge to the back of the part. $747 thousandths. Now the end of the next diameter is 940 thousandths. And then the distance from the bushing hole to the back of the part, according to the drawing, is 1 inch 260 thousandths. And the remainder is whatever is left there. Okay, so we've now completed the geometry that makes up most of our revolve. So you can imagine this is going to revolve around and cut out the center. So we're going to exit the dimension command and we need to close up the revolve. So we're going to start at the end here. We're going to go to center line. We're going to go back to origin and close up the loop. Okay, and we should have a fully constrained sketch. We're going to exit the sketch, going to select the sketch, going to look at it at an angle. We're going to go to features. We're going to do a revolved cut. Should preview it. In my case, it automatically found the center line, but if yours didn't, you need to select the center line and let's hit accept. And we should have now all these features cut in the center of the part. Now I'm going to show you a tool. It's called section view. And you select a plane and it allows you to section the part so that you can see it as if it's cut in half. And so that's what your section view shows, but you should have something like this on the center. And it's not physically cutting it apart, it's just a visual temporary mode. So you can deselect that and see the entire part. Alright. Now let's put the O-ring grooves in it. This is going to be very similar to the secondary piston. We're going to make one groove and then we're going to do a pattern. Okay, so we're going to go with our sketch planes visible. We're going to hit sketch on the front plane. As usual, our orientation is going to be normal to that sketch plane. We're going to do a corner-to-corner rectangle, snapping to the outside of the part, dragging down to the left, so it automatically puts the relationship to the outside diameter. We're going to put in a dimension from the inside edge to the back of the part, and according to our drawing, that is in our detail B, it's 40 thousandths by 40 thousandths. So we're going to put in 0.04, and then it has a width of 0.04 and a depth of 0.04. Alright, that should be our fully constrained sketch. We're going to accept that sketch. And we're going to highlight the sketch. We're going to look at it. We're going to look at the part in about a 3/4 ISO view. Okay, and we're going to make our temporary axes visible. So we have a spin center. And we're going to go Features, Revolved Cut, and we're going to pick on our axis. Goes all the way around. And now we've cut the single groove. Okay, so now we're going to do a linear pattern on this to create more of them. So we're going to go linear pattern. And our direction, we're going to pick the axis. In direction 2, we can just pick, say, the front plane. It doesn't really matter because we're going to select seed pattern. And I must have had the feature already highlighted, so it's assumed I want this cut revolve as the feature. And our spacing between is 40 thousandths groove plus a 40 thousandths crest. So it's going to be 0.08 for 80 thousandths. And we're going to put enough in that we can go all the way across the part. Oh, that's a few too many. Okay, I believe our drawing says 16, and it leaves one rib at the end that, depending on the tolerance, the part might be a little bit smaller than all the rest of them. Okay, let's look at our drawing. And it does say, yes, 16 grooves. And that's to increase the surface area of the outside so that it has more cooling surface. Alright, so we're almost done with this. We need to put holes in the end, so we'll do that next. So we're going to go Sketch, and we're going to sketch on the left side of the part. And we want to look at it in the same orientation as we're sketching, so we don't get lost on what's where. And we're going to look at our drawing. Now we have two holes, but they have different depths, so the same diameter, and the center hole's already here. So I'm going to go ahead and set up one sketch that's going to represent those, and then we'll select that sketch twice. Okay, so our sketch, of course, is in that plane. We're going to draw a circle. I'm going to draw another circle. We're going to snap that first circle, center of that first circle, to be coincident with the plane that's horizontal. We're going to do the same thing with the second one. Okay, we're going to hold the control key down and we're going to highlight both circles and we're going to make them equal in diameter. And we're going to put a diameter on one of them of 154, which would be right in the middle of that tolerance. 154 thousandths. And then we have a dimension that comes off center to the center of one of them. And in the drawing, that's 315 thousandths. And then we're going to do a center to center dimension. Which makes that 630 thousandths. I'll go back to that prior dimension. I'm going to make that 3 places so we can see the full number. Alright, looks like our sketch is fully constrained. We're going to exit this sketch. We're going to do an extruded cut, and we're going to select the circle that's closest to us, and then we're going to put it in a depth based off the drawing. So the drawing says the lower hole, which is closest to us in this view, it's 197 thousandths. So 0.197, and accept. Now when we created that feature, the sketch disappeared, and that's not really a problem because if you expand the cut we just did, it automatically makes the sketches invisible. So what we're going to do is we're going to show the sketch, because in this case we want to use it for another hole. Okay, so now it's visible. We're going to go extruded cut, and we're going to select the other circle, and the depth on that one's shallower, and it's 315 thousandths. And we're going to accept that depth.